Hello everybody, welcome to this FAULABER webinar. We create motion is our slogan. I see already connected several people from Europe, from Asia, from South Africa. And while we wait just a few seconds that other people can join us, I want just to tell you some words about FAULABER. FAULABER was founded in 1947. This year we celebrate 75 years of innovation. With more than 50 patents worldwide, FAULABER is a family-owned company. Now it's third generation, and everything started in the 50s when Dr. Fritz FAULABER reinvented the winding of a DC motor. At that time, DC motors were quite bulky, and with this revolutionary motor, FAULABER opened the door to thousands of new applications that were not possible to achieve with the old motors. The headquarters is in Schöneich, 20 kilometers south of Stuttgart. We have 13 international research, development, and production sites in Europe and in North America, 32 international sales and service locations around the world. We are growing, we are hiring, we have 2,200 people, more than 2,200 people, and we achieve more than 290 million euro of turnover. Just a few words about myself. Hello everybody, my name is Mario Zecchin. I work in the FAULABER Group since 2007, first as a product manager for motion control, and then I become responsible for the trainings and the e-learning systems and the webinars for our sales force. Let's start with this webinar, Drive System for Medical Application. With this webinar, we want to show you how to select the right drive system technology for your next medical application. Xiaolong is the chat partner. He will take care about the question coming during this webinar. Some questions will be answered for other questions. We will have a question and answer space at the end of this webinar. Today we want to show you an introduction of drive system for medical applications, starting from the DC motor to brushless motor technologies, stepper motor, linear actuators, encoder and gear to form a compact and powerful drive system solution. We will talk about drive electronics, and we have a lot of applications where our drive system can be implemented, can be inserted in order to get a high quality, long lifetime and reliable medical application. Then at the end, there will be time for a question and answer. The heart of FAULABER motor is coreless. You see here the winding. There is no iron core inside, so this means that the inductance is very low and the response to the current variation is very fast, so we can reach high dynamic movements with this kind of motors. We have also low inertia because no iron core inside, so this allows fast acceleration of our motors. And there is no magnetic attraction between the winding and the magnet because of the absence of iron core. This allows very smooth operation of the motor during rotation. There is a linear relationship between the voltage and the speed, and a linear relationship between the motor current and the torque produced by the motor. We have a higher performance in small volume because of the characteristics of the coreless motors. So DC motors have two types of technology. The first one is the precious metal commutation series. Precious metal commutation, SR, means precious metal brush and commutator, like this. And the R stands for rare earth magnets and typical neodymium that we use for our motors. This can be designed for 6 to 22 millimeter diameter, so very compact. They can be combined with a 2-3-channel encoder. They can be also combined with the gearheads. The second technology is the CXR and the CR, so the graphite commutated motor. This kind of motor is designed for high torque and long lifetime. The size comes from 13 to 38 millimeter diameter. The CR series is for top performance, the highest torque available, the most powerful characteristics, and the CXR is a good compromise between cost and performance. So it's a cost-effective solution. They have fast acceleration. We have explained before. The mechanical time constant is less than 10 milliseconds. Mechanical time constant is the time necessary to start from 0 to reach 63% of the maximum speed. And this is below 10 milliseconds, so the acceleration is very, very fast in this kind of motors. The rotor is balanced for a low vibration with high speed operation, and this kind of motor emits a lower emission electromagnetic interference in comparison with the iron core technology motors. Using DC motor, it's easy. You just have two wires to connect, polarity inversion included, because if you invert the wires, the polarity, the motor simply inverts the motion and you don't break anything. We have a fast start, and the speed can reach up to 25,000 RPM typically. The design is made to have a low torque ripple, so a low torque variation during operation of the motor. So the torque generation is very, very stable. The most efficient driving method for DC motor is apply directly the DC voltage. You just apply with the two wires, the 24 volt, for example, and the motor will run at its defined speed. There is another method to drive DC motor using PWM. In this case, we have a variable duty cycle to adjust the motor speed seen from the motor, and because of the characteristics of the coreless motor, we have to take care about the low inductance, so it's necessary to use high PWM frequency in this case to exceed 20 kilohertz, better 50 kilohertz. Our speed controller has 96 kilohertz, and our motion controller reach 100 kilohertz. So use high frequency. If you want to know more about this, we have some former webinars, and I want to show you in our website in the Faulhaber Drive System. You go to the news and event webinar archive, and here you have all the available records, all the available webinar that we have transmitted since the beginning, so you can learn about the drive system technology, selection, the DC motor, the driver, the gearhead, the stepper motor, all the motor technology, and the speed and motion controller technologies. That you can learn a lot about this kind of webinars. So coming back here, you must create a acceleration ramp, because in this case you can preserve the commutation system from shock due to high current during operation. So in this case you can also have a longer lifetime by also a factor of 5. So it's important to. Another motor technology is the brushless motor technology. They have the longest lifetime, and they can achieve the highest speed, up to 100,000 RPM for several medical applications. They have a possibility to develop high torque. The larger motor cannot reach 100,000 RPM, but they can deliver the higher torque. There is no mechanical commutation like in DC motor, because we have electronic commutation. So one motor needs one drive electronics for control speed or the position. For the speed controller series, we have a current limiter to preserve the winding from overheating, and the motion control series can be used for controlling in high precision, speed, position, and torque control. We can also integrate the speed and motion controller inside the motor, the brushless motor, in order to have a motion control system or a speed control system for plug and play function. The lifetime is very long. They may exceed 20,000 hours. The only limiting factor is the bearing. You can see one bearing here in the front and one bearing on the rear part of the motor. And if you respect the axial and the radial load published in the datasheet, you can get the longest lifetime as possible. Radial load is the load in this direction here on the shaft, and the axial load is the perpendicular to the shaft. For example, when you are using a conveyor belt system or a pulley, something like this. Another motor technology is the stepper motor technology. They move it with a high precision. Typically, we have a two-phase motor for easy positioning task. It's not so complicated to drive this kind of motor. Diameter size is from 6 to 66 millimeter. And for a small motor, we have 20 steps per revolution. Mid-size motor has 24. The 32 millimeter, the new one, has 48 steps per revolution. And then we have 100 and 200 steps per revolution for the ring motor. We have a possibility to have a through-hole shaft. We have a possibility to modify, to add, for example, some screw in order to get a very compact linear actuator like this. And we have the possibility to add gearheads and encoder. And the characteristics of the lead screw, with especially a lead screw with low efficiency, is that we can have auto lock possibility, so that it's possible to stop the load without using power. This is thanks to the residual torque of the stepper motor, in addition to the low efficiency of the gearhead of the lead screw. So this is very compact, and this makes it ideal for to move optical filters for focus, zoom of lenses, and so on. Then we have the linear motors. The linear motors are very silent, and the lifetime is very high. They are made only in two parts. One is the housing, and the second one is the rod with the magnet. We use integrated analog Hall sensor for the positioning and for the commutation. We have the family is four size from 8 by 30 millimeter, 12 by 47, 40 by 83, 14, and 20 by 70 millimeter. We have several stroke available, and the range of force in continuous operation is from 1 up to 9 Newton of force. We can reach high speed of movement up to 3 meters per second, and they are silent in comparison with the lead screw, for example, execution for linear actuator. But one strong point is the long lifetime. We can reach billion of cycles with low load in the applied to the shaft, and in presence of a linear guide, so with we can reach billion of cycles. We can exceed 300 million cycles when we have a asymmetric load. Asymmetric load means that we apply a load only on one side, and we get more friction in this point and in that point here. And this is the worst condition for linear motors. Then we have encoder and gearhead to extend the drive system possibilities. For precise positioning, we need a precise sensor, and with encoders, it's possible to have a very precise positioning system. We have encoder in optical technology, we have encoder in magnetic technology. We use one technology on the other depending on the application. If we have a strong magnetic field, we can use optical encoders because the light is not influenced by the magnetic field. But if we have a dusty environment, a harsh environment, most probably the best technology is the magnetic one, because optical encoders may fail in this case or have some problem. Then we have a multi-turn absolute encoder, and this is another interesting product, because we have the possibility with the multi-turn absolute encoder to memorize the position in the application, even in presence of a power off, because we have one wire to be connected with an external backup battery, and this conserves the memory position of in the application. So at next power on, there is no necessary to have a homing operation in order to get the real position in the application. Then we have a gearhead. They reduce typically the motor speed, increasing the motor torque depending on the reduction ratio, and they are available for combination with DC, brushless, stepper motor. In this case, you see a small brushless motor with encoder in the backside. This is the motor, and this is the planetary gearhead. And we also have the possibility to have the Spoor zero backlash gearhead for low consumption precise movement like this. This is an 8mm brushless motor with encoder and a zero backlash gearhead, all in 8mm diameter. For the control electronics, we have a speed controller, we have motion controller, maximum 30 volt of supply voltage, or we have the version with 50 volt of supply voltage with RS-232 connection, CAN open, and EtherCAT in this case here. We can also integrate the drive electronic inside a brushless motor in this small space to have a speed control system and motion control system. The advantage of this is that we have less wire, we have no disturbance between motor and drive electronics because they are in the same place, and we can spare a lot of wiring efforts while we build our machine. Well, before starting the session of the application where the drive system can be applied, just want to show you a short movie, and I will come back in a few seconds.
Faulhaber Drive Systems enable new solutions for robotics and automation in medical technology and patient care. Product features such as reliability, quiet operation, and autoclavability are often in the foreground. Faulhaber develops and produces highly dynamic industrial drive systems that are pivotal to applications in medical devices and laboratory automation. The ironless winding technology developed by Faulhaber enables the production of drive components with extremely compact designs and high power density. Customer-specific modifications facilitate an optimal adaptation to the application. With a comprehensive range of drive products and their connection via all common interfaces, Faulhaber offers turnkey solutions for integration in numerous applications in medical technology and laboratory automation.
Well, we have a lot of possible applications where the Faulhaber drive system can be used. One of these is the laboratory automation. This is needed to motorize the functions. And for example, high speed and high accuracy is more and more required. Increase of testing speed, increase of reliability is also a must. For this reason, we have a possibility to use our drive system for multi-axis system to move the sampling heads like this in order to have the highest number of testing in one machine. For this reason, we use a compact DC and brushless motor, can be used in several tasks for axis movement, for example, DC and brushless motor from 15 to 32 millimeter diameter, stepper motors. The last one, the new one just launched, has 48 steps per revolution with 32 millimeter diameter. Or for decapping and recapping samples, we can use a brushless motor like this, combined with a gearhead from 8 to 12 millimeter diameter. If we need to steer and mixing, we can use brushless motor from 16 to 32 millimeter diameter, or for high speed spinning, and we may use a brushless motor like this, maybe a 2-pole brushless motor from 16 to 32 millimeter diameter. For customized solution, we have a possibility to use a small DC motor with integrated gearhead and integrated encoder. This can be used, for example, in small taxis for probe test tube, and with a dedicated speed controller surrounded with sensor they can be autonomous in order to interact with other test tube analysis systems around this machine. We also have a gripping function with a variable force in order to grab delicate objects, delicate samples, tube, for example. And even in this case, we have DC brushless or stepper motors from 8 to 16. In this case, this is a 10 millimeter motor with gearhead and encoder. We have a compact drive electronics with torque control in order to regulate and to control the torque of the motor and the force of gripping force of the gripper. And for this reason, this kind of application is necessary a lightweight solution for high dynamic movements. And the complete system is given from a single source. This is also important. Automatic analysis machine like this one need high speed and high precision. We have standard analysis protocol, and for example, the multi-sample plate, like in this case here, they have a very small raster, below 10 millimeter. For this reason, it's necessary to use DC and brushless micromotor with diameter 6, 8, 10 millimeter. This is a 8 millimeter brushless motor with a gearhead. Larger motor can be used for the movement of the larger sample head, typically 13 to 22 millimeter for the axis. We also have an option for the lead skew, for example, in order to make a movement, linear movement in easy way. And brushless motor with integrated speed and motion controller can also be used for a very compact solution with RS-232 or can open a communication system. For lab analysis, we can also use linear motor. For pipetting or for sequential samples processing, this must be fast and this must be reliable. The solution with the ball screw typically can be noisy, can be expensive, the lifetime can be limited. The linear motor performs fast linear movement for multi-axis motion. A simple installation because we have one stator and one rod with the magnet inside, and we use analog Hall sensor for the position detection. Continuous force we have seen before from 1 to 9 Newton, and there is a modular integration. And in this case, you see there is a two motor for two axes, X and Z. The Z axis is also equipped with a magnetic spring for a gravity compensation, and they have very long lifetime, as we have seen before, more than 1 billion stroke in vertical operation like this. You have to change the linear guide before changing the motor. Another interesting application in the last years is the surgical robot for remote operation. On one side, you have the surgeon that operates on a console with electronics manipulator with a joystick to move on the other side the motors inside the surgery robot. A camera system on the other side can transmit the field view to the surgeon in order to get a view of what happens on the other side. So the actuator make all the positioning task performed by the surgeon even at 1,000 kilometers away. The motor must deliver high torque for high dynamics, be small, light, and typically we can use for the arm joint of the robot in this position here, we can use the flat brushless motor with encoder or a BP4. In certain application, we also have this ring motor, stepper motor with 200 line per revolution, where the 200 steps per revolution, where the wires can enter inside the motor like this. And we also have integrated electronic inside the motor in order to have a very compact motion control system, small and powerful. The haptic feedback is required because the surgeon has to feel possible obstruction or possible problem during the surgical operation. For this reason, we can use a DC motor with encoder, like for example this unit here, where it's possible to have a feedback of the force during the movement. This is quite easy to obtain because we have from the feedback of the motor, we have an encoder. The encoder gives information to the robotic arm controller. So we use the encoder as a command for the positioning, and the robotic arm controller perform all the movement that we can give. This is for one axis, and a manipulator can have more axes, for example, for complex movements. On the other side, you know that this kind of DC motor has a linear current to torque response, so it's quite easy to generate a torque proportional to the motor current. And this is possible from a haptic force controller. He gets the information of the force sensor, and based on this, he can generate a current to the motor, and the motor generate a torque. And so you can feel a resistance torque and transform it then in resistance force when you have the haptic manipulator. Other type of haptic feedback is with very small motors and with an eccentric connected to the motor shaft. And we can use small motors for vibration feedback, for example, with a hand tool. When the torque exceeds the value, you may have this small motor for generating a small vibration, and you can stop, for example, the tool. Or we can have the haptic with a high resolution encoder, with the haptic, the generation of the force measured by the force sensor. Another interesting application is the field of infusion pumps. Infusion pumps, they typically use battery operated device, so it's important to have a high efficiency motor. We can get over 90% of efficiency. They must be light, they must be with low noise and high reliability. The possibility to use integration with a gearhead, lead screw, and encoder for precise drug dosing, this is important. And we can use DC motor within this brushless motor or stepper motor in diameter size from 6 to 10 millimeter for the stepper motor, and 12 or 13 millimeter for brushless and DC motors. Also with lead screw, like in this execution here. Here you can see insulin pump, and the working principle is quite easy because you have a motor in the central part, and then we have a system of gears connected to the lead screw like this that pushes this syringe with the drug or with the insulin, for example, to be injected in the human body. So this is most will scare a lot of people. Dental treatment is painful sometimes, but let's say with the new generation of motor with high speed, and you can operate with lower time, so the pain is limited. This kind of motor now can replace the air-driven devices with a stable constant torque, constant speed, low vibration because we have a fine balancing of the rotor, and we have an optimal design for the hand tool in order to reduce the operating temperature during operation. We have several options for the shaft coupling, for customized winding, the LED, for example, for illumination in the front part. Sterilization is also required in this case. For this reason, we have a brushless motor, 16 millimeter and with a high speed up to 100,000 RPM, or for high torque operation, depending on the type of operation that we have to do with the hand tool. Brushless motor with 20 millimeter diameter like this, small motor, power up to 191 watt in this case. We can reach almost 100 watt. This is in comparison with the air-driven device is a factor of 2 or 3 on the power range. We have an interesting question here, okay? And for the selection of the brushless motor for dental application in case of high speed, let's say they ask 60,000 RPM and 8 millinewton meter. Okay, I want to show you one simple way to select this. We go to the web page and then you scroll down and you find the Faulhaber drive selection tool, and then you can just enter here the required speed, 60,000 RPM, available diameter. This is a hand tool, so we limit to 20 millimeter, the size, and the 100 millimeter, the length. The load torque was asked 8 millinewton meter, and then you can start the drive selection. And it opens this page where you can select a lot of possibilities. Let's make the first calculation like this, and you can see that we have two possibilities. Okay, then we can select this and we can compare the solution. What you can see here, the first side is that the motor temperature is quite high. 75 degrees for a hand tool is not recommended, but in this case, we have continuous operation. So this means that the drill is running in continuously. And if I have to visit a dentist with who operate continuously in my tooth, so I prefer to move away and to search for another doctor. In most of the cases, in all the cases, this is an intermittent operation. So this is just to make just rapid comparison, but in reality we have to modify the input value in order to get a real simulation for the application. For example, here we select intermittent operation, and then we can have this working point for amount of time of let's say 45 seconds, and the time on for let's say 25 seconds. And then we have to enter the number of cycles. Why? Because during on time the temperature of the winding increases, during off time decreases, but with many cycles the trend is to increase overall the temperature. So to reach a stable temperature, let's calculate about 60 cycles, and let's see what happens in the calculation. Remember, this is a simulation of our system. Then you can see we have three different options. One is also with a 1645, so very compact motor. Just compare the three solutions. And you can see, okay, 110 degrees definitely is not possible to use the smaller motor, but we can move with the other two motors. And for example, with the 2057, that is this size here, it's possible to reach 54 degrees for the hand tool after 60 cycles. So this is quite interesting. So if you look at the solution details, and you can see that the temperature of the winding and the house is increasing with the number, and we reach almost the maximum value after 60 cycles, and this is 52. So this could be the worst condition, for example. And you can download the file of calculation in several languages. For example, here you can just download it, you can open it, and you can see all the data that we enter about the number of cycles, the calculation mode, intermittent operation, the load torque, 8 millinewton meter for the timing, and you can see the temperature of the winding and the housing. And below you can see also the drive electronics that we suggest, and this is a link to your calculation. If you click on this link, you will open exactly the calculation that you made. If you want to change, modify input value with the chosen motor, you have 60,000. If you want to increase this to 9 millinewton meter and decrease the maybe the timing like this, and making 30 seconds like that, and then you can calculate with the new data, and you will see the new results. Motor housing temperature was 54, now it's 53 degrees, and so on. Once you are happy about this, you can click on the contact, and send us your message. Send me a quoting, or I would like to have a refined calculation, or I would like to have a special winding because I have a special working point for this. So we can have a let's say, modified product. If you need a special mechanical interface, a special flange, a special shaft, and so on, you can enter here, and you will be contacted from our sales engineer. I hope to get the right answers to your questions, and let's go on with another application, root canal treatment, always with the dental application. The endodontics treats the pulp of the tooth. Here is required to have a stable, constant torque with fine rotor balancing in order to reduce as much as possible the vibration, and to keep a low temperature because of the hand tool. And for battery operated, the last generation has a battery operated device. It's necessary to have high efficiency of our drive system. For this reason, we can use a DC motor with a precious metal commutation system, very high efficiency, very low power consumption, in combination also with a gearhead and with encoders, or we can use a brushless motor to have more power. Other application, especially in the last years, the point of care analysis needs a fast and reliable analysis of the sample test in order to detect virus or bacteria inside the blood samples. And we use a lot of motors from 8 to 17 millimeter diameter for easy sample rotation, or for fast spinning and high dynamic shaking. We can use brushless motor in the 8 to 16 millimeter diameter. We can also use stepper motor for the sample orientation, for the optical filter change, for shutter operation, especially in combination with a lead screw like this. Or we can have a combination with encoder and high precision gearhead. Speed controller and motion controller are always available. Just plug and play. You can see here we have a pin insertion, so you just plug it in your electronics and that's it. Prosthetics did a quantum leap in the last 5 years. This is because there was necessary to have high power motor, light and small form factor, high reliability, high dynamics and this was possible with the coreless motor technology. Every finger can be actuated individually with a small dedicated drive system with 8 and 10 millimeter diameter like this one. Here you can see a DC motor. We can combine it with a feedback for precise position control, and we can also use a powerful gearhead in order to have high impulsive load in this case. For the wrist movement, it's possible with brushless motor, or also with this disc stepper motor like this, with 200 steps per revolution. So in the last 2 years, we had a lot of vision with this kind of device, respirators and ventilation systems. They were a critical device for life support. The motor typically activates the blower to ensure a correct airflow inside the mask to the patient. Many respirators are also battery operated, so it's necessary to have a high efficiency of the motor, and it's required a very long lifetime and low noise and vibration in order to have a very reliable solution for the respirator and ventilator. For this reason, we have a DC motor with a diameter range from 15 to 22, like in this case. This is a 22 millimeter DC motor, very compact. High-speed ventilator needs 2-pole brushless motor, for example, like this, in diameter 20 millimeter. And high-flow ventilator can use flat brushless motor, 22 or 32 millimeter, also with integrated speed controller for a very compact blower. In this application, we develop a dedicated system for this high demanding application. For this, it was not possible to use a standard component off the shelf because the characteristics and the requirements were so high. So it was necessary to have a customized design for this complete blower unit. And this causes a complete specific motor design, a brushless motor with high speed and a sterilization possibility up to 134 degrees for 20 minutes, high speed operation with low noise, with low vibration level, but with high reliability and long lifetime. For this reason, we had a very close collaboration between both company, research and development departments, in order to design the best solution. And this has been a special tailored drive system solution for this specific application. So we have reached the end of this webinar for now. Just to summarize everything, we have seen that different type of application needs a different type of drive system. For example, sample analysis, surgical tool or dental tool, they need different characteristics of the drive system. The core length motor has a linear behavior between the applied voltage and the motor speed, and the current of the motor and the delivered torque. We have high dynamics, and this is ideal for high precision direct drive operation. We have high efficiency motor for battery operated medical device. Drive systems are built for reliability. All the motor technology can be delivered with high precision gearhead, for example, in this product here, or for encoder, ball screw, lead screw, in order to have a complete drive system. And the linear motor can be easily used for multi-axis positioning tasks. We have seen the application where linear motor can be used. Small drive electronics can be used for precise control of the motor, of the movement, and you have the possibility to have a customizable drive system solution from one single source, Faulhaber. Now it's your time. I just need some seconds to drink a little bit of water and read the last questions, and then to coming back to you for the answer. Just be patient a few seconds and I will come back to you.